Today, I'm doing something a little different from my usual videos. This is going to be a longer tutorial where we touch both the front end and the back end. On the front end, I'll be using plain HTML, CSS, and JavaScript. And on the back end, we'll use Node.js with Express. We won't be using a database in this video, but I do plan to expand this project later, so we might add a database and login functionality in future episodes, assuming we don't break everything first. Anyway, the project we're building is a simple weather app. I picked this one because it's relatable and it's a great beginner project for learning API calls in real applications. All right, enough talking, let's get started. I'm going to start by navigating into my backend folder inside the weather app project. First thing I'll do is initialize the project by running npm init.ey. That way I don't have to answer all those setup questions. Laziness is efficiency sometimes. While that's initializing, I'll quickly create a server.js file. Next, we'll need Express. So in the terminal, I'll run npm install express. As you can see, this creates the Node.js folder, and this thing grows faster than your unfinished side project, so I'm adding it to the .getignore file because you definitely don't want to push that to GitHub. Another file you don't want to push is the .env file, so I'll add that as well before I forget and regret it later. I'll go ahead. Since we're dealing with environment variables, I'll go ahead and install .env while we're here. If we quickly check package.json, you'll see both Express and .env installed. Inside server.js, I'll import Express and create an app instance. We also need a port to run the server on. I'll use port 3000, but you can use anything available, just don't fight the system ports, they usually win. I'll add a quick message just to confirm that the server is running. Let's test this real quick. I'll open the terminal and run node server. Hit enter, and nice, the server is up and running on port 3000. Now let's move to the actual project. I'll create a function called buildRequestURL. The name basically says what it does. It builds our API request URL. It takes a location and a request type as parameters. Inside the function, we'll return a URL string. For this part, I need to jump into the browser. Go to this weather API website. If you don't have an account, just sign up. It's free and quick. Since I'm already logged in, I'll go to my account and copy my API key. Back in the project, I'll create a .env file and add weather API key. Make sure you use your own API key. I'll be generating a new one after uploading this video, so no free rides here. Whenever you work with an API, always check the documentation. If you go to the docs section, you'll find everything you need, endpoints, parameters, examples, all that good stuff. This API actually explains things pretty clearly. I'm not going to go deep into how to read docs because I'm assuming you already know the basics, and if not, trust me, you'll learn very quickly. To make requests, we mainly need the base URL and our API key. I'll paste the base URL into the buildRequestURL function. I'm just pasting a version I already typed because typing long URLs live is a very effective way to lose viewers. Basically, we're inserting the request type, the API key from .env, the location and forecast days. I'm using 3 days since anything more wants money. I'll also wrap the lines so the code looks cleaner. Now I'll create an asynchronous function that fetches the weather data. Inside it, we make the request using fetch, store the response, convert it into JSON format, and then return the data. And that's it, pretty simple. Now we'll create a get route for the main endpoint. This route will also be asynchronous because we're calling our async weather function. Inside here, we read the location query from the URL. If no location is provided, we'll default to automatic weather based on the user's IP address. The API documentation explains how this works. We'll use the forecast endpoint for this request and return the JSON data. If a location is provided, we use the same logic, but replace automatic IP with the requested location. Then we return the weather data. Before we continue, let's test this quickly. I'll open Funder Client, which is a VS Code extension for testing APIs. Let me run the server again and send a request. And we get a server error. Classic. I just remembered I forgot to load dead of dev in the server file. Let me fix that real quick. Restart the server, run again. Okay, now I see the problem. I used the wrong port number. It should be 3000. Now it works. As you can see, we're getting local weather data back. I edited out the part showing my location because automatic IP reveals a bit too much sometimes, but you can already see how much useful information we're getting from the response. Let's continue. Now, I'll create another endpoint for autocomplete search. Here we read the query value from the URL again. Build the request link like before, but this time we use a search endpoint instead of the forecast endpoint. You can check the documentation if you want to see how that endpoint works. Let's restart the server and test this new endpoint. As you can see, it works correctly. See? For the autocompute request, it returns cities starting with certain letters. Let me try another one. Yep, still working. Always nice when the code behaves. Alright everyone, that's it for part 1 of this series. In the next video, I'll clean up the code a bit, and then we'll start working on the front end. Have a great day, and peace. In this video, we'll be cleaning up the code from the previous video. If you haven't watched part 1 yet, you can find it linked in the description below. To clean up the project, I'll be using Model View Controller. This structure helps keep the project organized as it grows. Let me go back to the file tree and create 3 new folders. The first one will be called Model. The second one will be Views. And the last one will be Controllers. In this video, we'll mainly focus on the Controllers folder. Inside the Controllers folder, I'll create a file called requestcontroller.js. Now, let me open the terminal because we're going to install something called Express Async Handler. I'll install it using npm. Make sure you type the name correctly, one wrong letter, and npm will happily give you something completely different. If you're wondering what Express Async Handler does, you can go to npm.js and search for it there. Basically, it's a middleware that helps handle errors in asynchronous routes, so we don't have to write try and catch everywhere. I definitely recommend checking out the documentation if you want a deeper understanding. Let me go back to Visual Studio Code. A quick check inside package.json confirms that the async handler was installed correctly. Inside the request controller file, I'll start by importing the async handler. Next, I'll cut the 2 functions from the server file and paste them here. While we're here, we'll create 2 controller functions, one for getting weather data and another one for the autofill search. Later, we'll export these so they can be used in our routes. Another thing you might notice is that I'm calling the API from the backend instead of directly from the front end. Technically, you can call the API directly from the front end, and for small or non-serious projects, that's usually fine. But in this case, I decided to route everything through the backend, partly for structure, and partly because I don't want to lose my wife's respect. The real reason is that handling API calls on the backend is generally safer and more scalable, especially when you're dealing with API keys or planning to grow the project later. So yes, you can call the API directly from the front end if you want. Just keep in mind that it's not recommended for serious or production level applications. Now I'll go back to the server and cut the logic inside the routes, then paste it into the controller file. Next, let's create a new folder called Routes. Inside that folder, I'll create a file called api.js. In the API routes file, I'll import Express and create an Express router. I'll also import the request controller, since we want to connect those controller functions to specific endpoints. For the main endpoint, we'll send a GET request that calls the getWeather function. For the search endpoint, we'll also send a GET request that calls the autofill controller function. And let me export the router before I forget, because that's the kind of mistake that makes you stare at the screen for 20 minutes. Now, back inside server.js, I'll use appuse to bring in the API routes. While I'm here, I'll also enable the Express middleware for JSON and URL encoded data. These will be useful later as the project grows. If you want to learn more about them, check the documentation on npm.js, because explaining everything here would turn this into a 3-hour video. Now that the code is cleaner, let's test and make sure everything still works. Okay, looks like we have a problem. The request keeps loading forever and there are no errors showing. Alright, I'm back now. I figured out the issue. Turns out I forgot to save the request controller file after making changes. You can easily check if your file is saved. The close button turns into a small white dot when the file isn't saved. As you can see, everything is working again after the cleanup. And that's it for part 2 of this series. In the next video, we'll move on to the HTML and CSS, the slightly more tedious part. But we have to do it. There are definitely easier ways to do this. You could use frameworks, libraries, or even full starter templates to speed things up. And honestly, that's completely fine. A lot of real projects are built that way, and there's nothing wrong with it. I chose to build this using plain HTML, CSS, and JavaScript because I wanted to keep everything simple and transparent. When you do things from scratch, it becomes easier to understand what's actually happening behind the scenes. So, if you're watching this and thinking, I could do this faster with a framework, you're absolutely right. This is just my personal approach for learning and teaching. Okay, in this video, we'll be building the HTML and CSS for our project. Just like I mentioned in the last video, if you want to check that one out, the link will be in the description. Let me quickly create the file structure for the front end. Now I'll link the CSS and JavaScript files to the HTML. For the JavaScript file, I'll use the defer attribute. If you don't know what defer does, you can check the meters DN reference. Basically, it tells the browser to wait until the document is fully loaded before running the script. People familiar with web scraping or bots might already know how useful that is. I'm actually planning to make a web scraping video someday, but that's a topic for another day. For icons, I'll be using Font Awesome. It's taken a bit long to load, so while that happens, I'll continue with other parts. Inside the body of our HTML, I'll start by defining a header tag. Inside the header, I'll create a div with a class called input container. This will hold our input field, and I'll set its position to relative because we'll later add a drop-down right below it. Now that Font Awesome was loaded, and we quickly copy the link. Inside the input container, I'll add a text input with the ID search and a button with the ID button search. For the button icon, I'll use the Font Awesome magnifying glass. As you can see, the page is already starting to take shape. Below the button, I'll create a div with a class called autofill and add some span elements just for visual purposes. These are temporary and I'll remove them later. Now that the header is done, let's move to the content section. I'll create a main tag and inside it add a div with an image. Let me quickly run the server because I want to grab a weather icon link to use as a placeholder. I'll set the image ID to weather icon, and this is how the icon looks for now. Next, I'll add an H1 element for the current temperature and another element for the weather location. Below that, I'll create a section for additional details. Inside it, I'll add a div called Other Weather Details, and inside that, I'll create two span elements, one for wind speed and one for humidity, with temporary placeholder values. Finally, we'll add a footer. For the footer, I'll reference the website where we got the API. If you scroll to the bottom of their site, they politely asked for attribution, so we'll give them some credit. I'll copy their HTML snippet and paste it into our footer. And that's it for the HTML structure. Now we move to the CSS part of the project. This section is mostly personal preference, but I want to show the full process in case someone watching is interested in the styling logic. Let me rearrange things a little so I can work comfortably. First, I'll style the body. I'll set display to flex, align items to center, and justify content to center. I'll reset the margin to 0, set the font family to Arial with some fallback fonts. and add a blue gradient background that my wife picked. The height will be 100 viewport height. Now for the header styling, I'll set the position to fixed, with top left and right set to 0. Then display flex, justify content center, align item center, and add a padding of 1 rem. As you can see, the header now stays nicely at the top. Next, I'll style the input so that the border doesn't show when it receives focus. Still in the input area, I'll style the input container as flex. Align item center, justify content center, and set a maximum width of 1400 pixels. For the input field itself, I'll set padding to 1 rem on the sides. Height to 2 rem. Border radius to 1.5 rem. Border to none, maximum width 400 pixels. Minimum width 95 pixels, width 90%, and a small margin on the right. As you can tell, this isn't the cleanest CSS in the world. I might make another video later, just cleaning and refactoring the styles. For the placeholder text, I'll add some left padding. Now for the search button, I'll set the cursor to pointer, width and height to about 2.2 rem, border radius to 50%, and remove the border. Next, I'll style the autofill span elements. I'll add padding, a light bottom border, set the cursor to pointer, and add a short transition for the background color. I also want to quickly mention something about the CSS in this project. I'm not really a CSS specialist, and to be honest, I don't spend a lot of time working on styling compared to other parts of development. My main focus is JavaScript and the logic side of things. That's where I'm most comfortable and where I usually spend most of my time. That being said, I do know enough CSS to build clean and functional layouts, even if it's not the most advanced or fancy styling you'll ever see. So if you notice that the CSS here feels simple or a bit straightforward, that's intentional. The goal of this project is mainly to focus on functionality, structure, and understanding how everything connects together. You can always improve the styling later, and honestly, that's usually how real projects go anyway. So think of the CSS here as practical and good enough to support the JavaScript, not as a masterclass in design. For now, I'll set the autofill container to display none. Later, when we work with JavaScript, we'll show it dynamically. I'll also set the flex direction to column, width to 100%, position it slightly below the input, add a white background, and a softbox shadow. Now that the header styling is done, let's move to the content. I'll set the H1 size inside the main section to 4 rem. The weather icon image will have a width of 7 rem. Span elements will have a large font size. The main element itself will be displayed as flex, with column direction, centered alignment, and white text color. Now for the footer, I'll set the background color to black, text color to white, position fixed at the bottom, and center the text. I'll also change the footer links so they appear white. To style the other detail section inside the main tag, I'll add a top margin of 5 rem. With 90%, display flex, justify content space between, and add some padding. Let me quickly test the responsiveness. Okay, that looks a little weird. I'll set the mean width to 90%, and now it looks much better. The autofill container is also working fine, and that's it for this video. Peace. In the last video, we created this basic weather app page, but as you can see, it's not functional yet. So today we'll be adding the JavaScript logic that brings this weather app to life. Let me open the index JavaScript file. Remember, we linked it to the HTML in the previous video. I'll start by selecting all the elements we'll need from the page. We'll grab the search input, the search button, the autofill container, the weather icon, the current temperature, the selected location, the wind speed, and finally the humidity. First, I want to check if the front end can actually connect to the back end and receive data. So I'll create a function called getDefaultWeather. This function will fetch data from localhost on port 3000 and simply log the result to the console. and we immediately get a course error. Classic. To fix this, we need to go back to the backend. In the terminal, I'll install the course package. Now I'll create a new folder called config, and inside it I'll create a file called courseoptions.js. Inside this file, I'll configure cores by creating a whitelist array. This is basically a list of domains that are allowed to access our backend. Next, I'll create an object called courseOptions. Inside it, the origin will be a function that receives an origin and a callback. Here we check if the whitelist contains the origin, or if there is no origin at all. If that condition passes, we call the callback with no error and allow access. Otherwise, we return an error saying the request is not allowed by CoreEnds. I'll also set the success status to 200 and then export the options object. If you want more details about CoreEnds, check the documentation on npm.js. I won't go too deep into it in this video. One quick note, when deploying your app, you should remove the no origin allowance. I'm only using it now because tools like Thunder Client sometimes send requests without an origin and they get blocked during testing. Now that cores is configured, let's go back to the server file. Here we'll import cores and use it with our cores options object. We'll also create a middlewise called credentials. This middlewise uses the same whitelist. Inside it, we check if the request origin is allowed, and if it is, we set the response header for access control. And of course, don't forget to call next at the again. Back in the server file, we'll use the credentials middlewise. Now for development, this setup might still give me issues, so I'll temporarily set the CoreEnds origin to allow everything using a wildcard. This is just for testing. Let me restart the server before both going back to the front end. Now you can see the weather data showing up in the console. Good, that means the connection works. Next, I'll add an event listener to the document so that when the page finishes loading, it automatically calls the getWeather function. I'll also add an event listener to the input field. This will listen for input changes, and whenever the user types, it will trigger a function called show possible locations, which we'll create now. Let's create that function. It takes a region as a parameter. Inside, we fetch data using the search endpoint with the region as a query. Once we get the data, we need to display the locations inside the autofill container we created earlier. I'll create another function called display locations. This function receives the data. First, I'll reset the autofill container every time the function runs so that locations don't keep stacking forever and turning into chaos. Then I'll check if data exists. If there's no data, I'll highlight the input border in red and return early. If we do have data, we remove the red border and loop through each location. For each location, we create a span element and append it to the autofill container. Inside the loop, I'll set the class name to found locations and set the text to include the city name, region, and country. Make sure your spelling matches the API response exactly. APIs are very unforgiving about spelling mistakes. Now when I start typing, you can see the autofill working. Next, we need to make those items clickable. I'll declare a variable called found locations that selects all elements with that class. For each one, I'll add a quick event listener. When a location is clicked, we call the getWeather function using the clicked location as input. I'll also update the search input value to match what was clicked. Now let's define the getWeatherData function. This will be an asynchronous function. Inside, it's the usual fetch, response, and JSON conversion like before. Once we receive the data, we'll call another function called displayWeather, which we still need to create. Let's create the displayWeather function. This will be our last function for this video. First, I'll set the image source using the icon provided by the API. Let me quickly inspect the data so we can see the correct path. You can see the icon lives inside the current condition object. Next, I'll set the current temperature using the temperature value from the API and round it to 0 decimal places. The rest of the text fields will be updated the same way. For wind speed and humidity, I'll use inner HTML instead of text content, so I can include phonos and icons. And just like that, our weather app is fully functional. The text looks a little big right now, but that's a styling issue for another video. Before ending, let me make the button actually do something useful. I'll add a click event listener so that when the button is pressed, it selects the first location in the autofill list. As you've probably noticed, the JSON data we receive from the API is actually very large. In this tutorial, we're only using a small portion of it just to get the core features working. There's still a lot more data that we can take advantage of, and the project is far from finished. In future videos, I'll focus more on the front end and start expanding this into a bigger application. That means multiple pages, more advanced UI, and eventually a login system that will let us use much more of the data provided by the API. So think of this as the foundation. We're starting simple, but we'll keep building on it. This series is going to continue, and I'll keep adding features and improving the project over time. Honestly, for as long as it makes sense to keep growing it. So if you're following along, expect more updates and new features in the next videos.